And another exciting lesson here in chapter 6. This is 6.4, the quadratic formula. So this is a formula that you will have to remember, and you will want to remember it because it is used very often, not in just this year, but following years. So you will need to remember it. What is the quadratic formula? The quadratic formula finds you your x-intercepts, and it is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, where do these a, b's, and c's come from? Remember, the standard form is a x squared plus bx plus c. So the a, the b, and the c are all coming from this standard form here. Now, there's a YouTube video that helps you remember the quadratic formula, and I'll just play that. So hopefully that helps you remember the quadratic formula. And if not, the link is here so you can follow it and watch it again to try and help you remember. So it's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, how can we use the quadratic formula? So I mentioned already that it's a way of finding the x-intercepts. So we already did this in the previous section where we were able to factor it. But what if you cannot factor it? Which we've had those situations. The reason you cannot factor it is because either it's not possible to factor it, meaning it will not find x-intercepts, so your graph would look something like this. There are no x-intercepts. Or the factoring are giving you irrational or rational numbers, that the decimals that you would not be able to do. So if you're ever struggling with factoring, what you can always do, so when in doubt, is use your quadratic formula. This will always find you your x-intercepts. Now, a question could say, how many roots or how many x-intercepts does this quadratic have? And if you're simply to ask for the number of roots, you can actually look at a shortcut. This is called the discriminant. So the discriminant is b squared minus 4ac. And if you remember this from the quadratic formula, it was negative b plus or minus b squared minus 4ac, all divided by 2a. So the b squared minus 4ac is the part under the square root. How does this help you tell you the number of roots? Well, if this discriminant is greater than 0, bigger than 0, so 1, 2, 3, 4, 5, this will always tell you that there are 2 roots or 2 x-intercepts. If it's less than 0 or a negative number, this will tell you that there are no roots, which makes sense because if it's under the square root and you end up with a negative number, can you take the square root of a negative? If you try it in your calculator, you will get an error. You cannot. If this equals 0, there will be 1 root. And so what 1 root looks like is when it touches the axis and it goes right back up, or it could open down as well. So these are the different criteria to tell, even if you will be able to find x-intercepts, is if it's greater than, less than, or equal to 0. Another thing that we can mention using the a, b, and c from the standard form is another way to find the vertex. So previously, we've been able to get the vertex from vertex form, which putting it into vertex form, we'll eventually get to that. That's in section 6.1. The other way we've been able to get the vertex is to factor it. Once we've been able to factor it, we use those 2 x-intercepts, we add them up, and then we divide by 2. Once we have that, we sub it back into our equation and we get our full vertex of x comma y, or h comma k, if you remember from chapter 4. Now we have a new way using the a and the b that you can actually find your axis of symmetry by doing negative b divided by 2 over a, which you get your a and b from standard form. This only gives you the x value, just like we got here. So from this x value, you still have to sub it back into your equation to find the y. But either way, this is another way of finding the part of the vertex. And so if the question asks you to find the x-intercepts using the quadratic formula and to graph it, you can use this to find the vertex. So we're going to do an example where we're only going to look for the x-intercepts, but you could have to graph any of this, but we're just going to use the quadratic formula. So in order to use the quadratic formula, it needs to be in standard form. This is currently not in standard form. However, you can get it into standard form by expanding. So remember back from last chapter when you have it squared. What that squared means is you take the same thing and you multiply it by itself. So if we expand this part in here, we end up with x squared minus 2x plus 4 plus 3. And collecting like terms, we then have x squared minus 4x plus 7. So we have this in standard form now. What is our a, what is our b, and what is our c? We get them again, the coefficients. The a is in front of the x squared term, the b is in front of the x term, and the c is all by itself. So our a value is 1, our b value is negative 4, and our c value is positive 7. Going back, we have to find the x-intercepts. So we're going to use the quadratic formula, which is negative b plus or minus the square root b squared minus 4ac, all divided by 2a. So now we can put in values. So negative b, our b value is negative 4. So if we put in our b as negative 4, then we continue on plus or minus the square root of b squared. Our b value is negative 4, and then square it, minus 4, and then our a value is 1, and our c value is 7. Then we all divide it all by 2 times our a value, which is 1. So then we have negative and a negative. This is positive 4 plus or minus the square root. Negative 4 squared is positive 16. And then we have minus 28, all divided by 2. And we continue on. 4 plus or minus the square root. If we do 16 minus 28, so then we would get negative 12, and then it's all divided by 2a. Now remember, we have a plus and minus here, so this means one of our x-intercepts is 4 plus the square root of negative 12 divided by 2, and the other one would be 4 minus the square root of negative 12 divided by 2. And then we could type this in, and we would get a value for x and a value for x here, and you'd get your two x-intercepts. I want you to remember back, though, technically we could have stopped, because if you look at the discriminant in here, it is negative 12. This means that there are no x-intercepts, so we won't actually be able to get values for our x here. However, if this was positive, you would actually be able to simplify this, and you would be able to get numbers here and for the other one as well. So in this case, there are no x-intercepts, but you should be able to go further by doing 4 plus the square root of the number, and then all divided by 2, and then the minus 1 as well. If you have any questions about the quadratic formula, please write those down, and we will take them up in class.